Welcome back everybody to Geology 101. This week we're going to cover sediments and sedimentary rocks. So that's going to be these two right here. We got our sediment and then we have sedimentary rocks. What is sediment? What are these rocks? How do they form? For our first section, we're going to break down some rocks. Nice and heavy rocks. We're going to hit them with a hammer, do whatever it takes, break them into pieces. Okay, well maybe it's not us breaking down the rocks. Maybe instead it's some kind of natural process, but this begs the question, what in nature could cause a rock to break down like this? And it's important to know before we go any further, just for background here, all the rocks on the surface of the planet and some of the ones underneath the surface are being broken down constantly. Any rock that is exposed to the elements is going to get broken down eventually. So looking back at our big picture, we have our rock cycle here. We have solar energy as our main input driving things to break down, either through wind, through the evaporation and precipitation of water, through the freezing and thawing of ice. We've taken these big mountains, these chunks of igneous rock, and now we're going to break them down into pieces. And what happens to those pieces? They become sediment, which is later deposited as a sedimentary rock. But then there's two different processes here going on. We have weathering and we have erosion. So the chemical and physical breakdown, the hammer, is weathering. And the part where we're transporting all the sediments away, that's going to be erosion. This is the best way to remember it. So weathering breaks the rocks down, and erosion carries them away. So then this is the setting, the kind of mental picture that you want to keep in mind for the whole section. We have our big chunk, maybe of igneous rock, and it's being exposed to the elements, rain and rivers and freezing, thawing ice, and it slowly breaks down. Those chunks are moved somewhere else by erosion, maybe by gravity, maybe by a river again, maybe by wind, and then laid down. Okay, so there's this process of physically breaking rocks down into smaller pieces, the hammer. And one way to do this is through mechanical weathering. This is a physical process. You imagine that nature has taken a hammer to a rock, it breaks it down into pieces, but importantly, those pieces are still made out of the same stuff as the original rock. They haven't changed chemically. And there's going to be four main types of mechanical weathering that we'll discuss. And then of these four types, the first one, sheet jointing, is kind of unique. It's different from the others, all these different wedging processes, which are kind of similar. So first, what is sheet jointing? Well, the best way to think of this is to think of like exfoliating your skin. You have these layers that come off one by one, and as a result, you have taken little bits of skin physically away. Well, the same thing happens with rock. You imagine you have a big chunk of rock like this, is exposed to the sun during the day, and it's heated so it expands, and then at night it contracts and cools, and as a result of this over and over, expanding, contracting, it slowly begins to shed in layers like this. Frost wedging, on the other hand, is kind of a different process. So most rocks, when they're exposed to the elements for any length of time, will develop all these cracks in them. And what happens here is that rainwater or water from some other source comes and it fills these cracks in. Later, maybe at night, when the temperature drops, that water freezes. And, well, we know that whenever water freezes, it expands. And actually, it expands with a ton of force, enough to break rocks entirely open, like this. It's kind of similar to what happens if you leave a soda can in the freezer for too long, right? You come back and it's popped open. This is the frost wedging process. Root wedging is very similar. So we have our rock, and our rock already has some cracks in it because it's exposed to the elements. And then a tree comes along and grows into those cracks and lays roots down, and slowly over time, as the tree grows, it wedges the rock open. Now, salt wedging is a little bit more like frost wedging than it is root wedging. You imagine that we have rock, and it's being filled with salt water. Maybe it's right next to the ocean. And as that salt water dries and evaporates, it leaves behind these salt crystals which grow. And as those grow, they really want to expand very, very badly. So badly, actually, that it will carve out sections of the rock and wedge it open. So what's our setting? We have salt water inside cracks of a rock. The water evaporates and leaves these salt crystals behind. And as those salt crystals grow, it breaks the rock open. So everything we've done so far has been mechanical weathering. We're breaking the rocks down, but we're not changing what the parts are made out of. Chemical weathering, on the other hand, is very different. Here, we're actually chemically reacting with the rock, chemically changing what the rock is made out of as part of the process of breaking it down. And we're going to talk about three main types here: oxidation, hydrolysis, and solution. So our first process is oxidation. This is what happens whenever you have a rock that is exposed to oxygen and water for long periods of time. And it's the same process that you would get for like normal rust, regular rusting of something. And just like with regular rust, it's going to change the color of the material, in this case change the color of the rock. And just like with normal rust, it's going to mostly happen whenever you have a rock that has a lot of iron in it. Our next process is hydrolysis. So it's got hydro in the name. You should think of like water. This is what happens whenever water chemically breaks down a rock. Now, obviously, if you go into your kitchen, you get a glass of water, and you drop a rock in it, they're not going to react. But over long periods of time, tens of thousands, hundreds of thousands, or even millions of years, water can actually break down rock. And you see this a lot with granites, this sort of light-colored igneous rock. It rounds them off and creates these sort of bulbous-looking figures you can see here. So our last type is going to be dissolution weathering, otherwise known as solution weathering. For our class, those are going to mean the same thing. And what is the process here? You start with carbon dioxide in the atmosphere. And that carbon dioxide interacts with water vapor and with rain that's already in the atmosphere. And as a result of those two interacting, chemically reacting with each other, you get a little bit of what is called carbonic acid. And later, whenever there's precipitation, the rain carries that little bit of carbonic acid with it and becomes ever so slightly acidic as it rains down. And this is not necessarily the extreme case of factories polluting, making acid rain. This is pretty much all rainwater everywhere. It's going to be ever so slightly acidic like this. It's just acidic enough that if it meets the right kind of rock, like limestone, what this statue and what a lot of gravestones are made out of, it's going to slowly eat it away, slowly chemically dissolve the rock. And you can actually see this happening a lot underground. Whenever you have big cave systems that form, it's the same process as what dissolves the statue here. Rainwater comes down and seeps into the ground. That rainwater is ever so slightly acidic, and it slowly eats away at whatever rock is underneath the surface, forming this cavity known as a cave. So what are all the different things that can make weathering go fast or slow? Well, the number one factor is climate. What is the temperature, hot or cold? How much rainfall is there, wet or dry? The next factor is the surface area of the rock. Is there a lot of rock exposed, lots of cracks in it, which increase the surface area, more places for water to get into and react? The next factor is going to be the composition of the rock. Some rocks are really resistant to weathering and stand for a long time, and others weather really easily and quickly. And the last factor is time. How long has this rock been exposed to the elements? So out of those four factors, climate is the one that is most important. What is the average weather pattern in that area? Is it hot? Is it cold? Is it wet? Or is it dry? Now, chemical weathering specifically is going to be a lot more active in areas that are warmer and wetter. You have more water. The chemical reactions take place at a faster rate when there is a higher temperature. On the other hand, if you have a cold, dry region, somewhere with a lot of ice, you're going to get more mechanical weathering, a lot more things like frost wedging that break down the rock physically. Now, you might notice that on the diagram here, we have temperature on the left, hot to cold, rainfall at the bottom, wet and dry. There's kind of this big gray region which is missing. I will give 5 points of extra credit to anybody who can email me and tell me why this region is missing here. So in this first section, we've talked about all the processes that break rock down, all the weathering processes. And now we're going to talk about, well, what happens to the little bits of rock that are broken off? What happens to the little pieces that have been broken off, these things called sediments? And you should know that the first number in the access code for this week is going to be 6. First number in the access code is going to be 6. Have a good one.